Welcome to the pool part 2. Now you should have watched the video for part 1, so there's some things we need to add. In part 1, this angle here was 78 degrees. We converted it to radians in part 1 and we got radians of 1.3613568117. That was from part 1. We talked about putting a wall across there and we found the length of that wall. And part 1 also described putting in an arc to make this end of the pool a sector with a radius of 20. That was all in part 1. Okay, so reading the questions off your sheet, the third part to this problem said, is the new paddling pool area bigger or smaller than the original design? Now the original paddling pool was a triangle, so let's find the area of the triangle. There's a formula for that, so looking on our sheet, half times A times B times sine of the angle in between. So we'll just check we've got an A and a B, or two sides, and the angle in between. That's what we need to find the area of a triangle that's not right angled. We need two sides and an angle in between. And for triangles, that formula needs the angle in degrees. It's really important. So it's going to be a half times one side times the other side times the sine of the angle in between the two sides. That angle has to be in degrees. Okay, so you can find your calculator and work that out as well. And the answer is 244.5369 metres squared. Alright, so that's the area of the triangle part, the old design. Now we'll try the area of the sector, which is the new design. And there's a formula for that too, which is very easy. That says the area of a sector is half times the radius squared. The radius of that sector, if you read the question again, was 20, times the angle, but the angle needs to be in radians. So this time we have to use the angle in radians. And working that out on a calculator, we get 272.27134 metres squared. The actual question said, is the new pool bigger or smaller than the original? We can see that the area of the sector, the new shape, is bigger than the original shape. So you'd need to write a sentence that says the new design has a bigger area than the old design, and you could work out the difference between the two. I think it comes to about 27 metres. Okay, and that finishes that question. You can write a sentence to reply. Okay, the last part, and this is the hardest part, says, what percentage of the total pool does the new curved paddling pool cover? What percentage? Well, we know the area of the new part. It's down here. This is the area of the new part. So we want to compare that with the area of the whole shape. We've got the area of half of that new shape. I think we're going to have to find the area of the other part. It's just a triangle. We've got two sides, but what we'll need is that angle in there. We'll need to know that angle, so then I can do the area of a triangle formula, half times 38 times 30 times sine of the angle in between. So let's think about how we could find that. We know this side as well. We found that in part 1. It was 28.58475 metres. So I see I've got three sides and I want to find that angle. So three sides, one angle. That means we're going to be using a cosine rule for angles. So it looks something like cosine theta, or the angle, equals the two sides either side. You can look at your rule on your sheet, formula sheet. 38 squared plus 30 squared minus the third side opposite the angle, and there's a decimal in there, we'll use the decimal in our calculation, divided by, and you need brackets around all of that, 2 times the 38 times the 30, and we'll need brackets around that. Right, I'm running out of room definitely. So you'll need to work that out on a calculator, and you should get something like, I'm not sure what you get, but when you find the inverse cosine to find the angle, you get 47.956 degrees. That's that angle there. So you'll need to work through that calculation on your calculator carefully, come up with an answer for that, and then of course to find the angle you're going to need cosine inverse, or cosine to the minus 1 of the answer to that, to get that degrees. Okay, so now that we've got that, we can work out the area of this triangle here. So perhaps if we call this triangle 1 and this triangle 2. So the area, and of course you'll need more space. You can be using a lot more space than me. Equals half times 38 times 30 times sine of the angle in between that we've just found, the 47.956. And you can use answer if you've still got it on your screen. Work all that out, and we end up with 423.3010, and there's some more numbers. Right, so we've got the area of triangle 2. I've got the area of triangle 1, here it is over here. So therefore we can find the total area of the whole pool. You will have a lot more space than me to set this out. So we need to add this number here, the 244, plus the 423, and hopefully on your calculators you get the same as me. Meters squared. Now we're nearly at the end of our problem, because the problem was what percentage of the total pool does the new curved part actually take up. So to find the percentage covered, and I'm going to run out of room here, so you'll need to set it out. I need the area of the smaller part, the new sector. We need to compare that, and to compare means to divide by the total area of the pool times 100 to make it a percent. And if you work all that out in a calculator and do some rounding, 40.77% to 2dp, which looks about right. This bit here is about 40% of the total pool.